What was I saying? Oh yeah, so we'll have a look at some examples now. Okay, so the first example we'll just calculate how many roots there are. We don't want to know what the roots are, we just want to know how many roots there are. So a mistake a lot of students make, like in the exam, is they think the question wants the roots. We don't want the roots, we just want to know how many roots. So just to make it perfectly clear, discriminant is b squared minus 4ac, and if the discriminant is positive, that means we have 2 roots, and if it's 0, that's 1 root. Yeah, and then negative is no roots. Yeah? Okay. Right, let's have a look at our first example. How many roots does this have? Okay, let's do this one. Quite straightforward. So the discriminant is b squared minus 4ac. So that's 49. What's that? Plus 40, isn't it? Which is 89, which is bigger than 0, which means therefore 2 roots. Pretty straightforward. Yep. Okay. So let's look at another one now. If we can scroll down. Okay. Can I do the next one? Yeah. Yeah. Let's see. Okay. Same question. How many roots does minus k x squared plus k plus 4x minus 3 have? Okay, so you notice a big difference here is that we actually don't have numbers, so we don't know what the k is. Although I do know at least one thing about the k, and what's that? No, actually, it could be positive. The only thing we know is k is not 0, because it wouldn't be a quadratic then if it was 0. But apart from that, I don't know anything about k. But I do know, to find out how many roots I have, I should calculate the discriminant. So let's see what happens if I calculate. So the discriminant equals b squared minus 4ac. Now right now, we can't tell if it's positive or negative or 0. We don't know, because we don't know what k is. So we'll have to simplify a bit. K squared plus, let's see, 8k plus 16 minus 12k. Yeah. So that's k squared minus 4k plus 16. Now, do we know if it's positive or negative yet? We don't know. Or do we? Next step then. Yeah. If I do this, I can say x minus 2 squared, yeah, 16 minus 4, so 12 then. Now something quite interesting happens. I know that this is positive, because it's a positive and a positive. So I know that this is positive. So I know that the discriminant is positive. Even though I don't know the k, I know that it has two roots. So this has two roots. We know this. Even though I can't actually find the two roots, I know it has two roots then. Yeah? Okay. Can I scroll down? Yes? Yeah. Okay. So far we've just done two examples. How many roots with the numbers known? How many roots with the numbers unknown? So now the last type of question we'll have to do is we know how many roots there are and we have to work backwards to find the missing number. So for example, and I'll use that in a moment, let's say 4k minus 5x squared plus minus 8k minus 2x plus 4k plus 3 has two distinct real roots. And what I need to do, find k. So I tell you that this has two real roots, and I want to know something about the k. The only thing we really know so far is that k cannot equal, not quite this time. Say again? 5 over 4. Because you want this part here to not be 0. Yeah? But k itself could be 0. For example, if k was 0, we'd have minus 5x squared minus 2x plus 3. If it was 0, so that's okay. Right, so if it has two real roots, we know that the discriminant is positive. So we know that the discriminant is positive. Just when the exciting part was about to happen. Okay. Okay. Right. So we know the discriminant is positive, so that means we know that b squared I want my password. Okay. Right. As I was saying, so we know the discriminant is positive, so we know that b squared minus 4ac is positive. Okay. We'll have to simplify this, of course. So let's simplify it. Opening this up, we get 64k squared plus 32k plus 4, yeah, minus 4, and then opening this up, 16k squared, and then I'll go with this one next, plus 12k, yeah, minus 8 in total, thanks, minus 15, bigger than 0. So we get 64k squared plus 32k plus 4 minus 64k squared. Together, these make minus 8 by minus 4 plus 30. Are you telling me I made a mistake, or are you telling me the next part? Yeah. And then here 12 minus 20 is minus 8. And then minus 4, minus 32. Plus 32, because it's minus and minus. Plus 60. Now what's nice here is that this cancels with this, and we have 64k plus 64 is bigger than 0. So k plus 1 is bigger than 0. So I know k must be bigger than minus 1. Now what did I say earlier about k? Yeah, not equal to 5 over 4. But this isn't quite the full answer. This isn't quite the full answer, because earlier I said k is not equal to 5 over 4. And if I tell you k is bigger than minus 1, would that include 5 over 4? Yes. So I also have to say k not equal to 5 over 4. Now, this is worth looking at, because if it was 5 over 4, we wouldn't have a quadratic. What would we have? Be a linear, because the x squared part is 0. So I just want to graph what's happening here. I think it'd be worth seeing. I'll just give you a second to write this down, and then I'm going to do some graphs. I still see a couple of people writing. Are we okay to continue? Okay, so let me just type this quadratic down. Y equals, what was it? 2, where's it gone? Minus 8k. Maybe someone can read it to me, because I can't see. What is it? Minus 8k minus 2x squared plus minus 8k. Okay. Yeah. Okay, was this it? Yeah. So I said, as long as k is bigger than minus 1, it should have 2 roots. Now, is there a mistake in this? Minus 8k minus 2 is right. No, it's not. Oh, okay. What is it then? 4k, oh yeah. Just that's the only part to change? Okay. Now it's all good? Alright. So I said as long as k is bigger than minus 1, we'll have 2 roots. So let's test that out. Let's put in a number for k. Let's say k is something like minus a half. That's bigger than minus 1, right? So we'll put that in, and we'll graph this. And yes, it has 2 roots. Now, what do you think happens if I put in a value of k which is not bigger than minus 1? Will I have 2 roots? No, because I said k needs to be bigger than minus 1. So let's put in something like k is minus 2. Okay, let's graph this. You see? This quadratic doesn't have 2 roots. Now, something interesting happened when we said k is 5 over 4, which is 1.25. So let me just clear that and put in this here. So I won't quite put in 1.25. I'll put in 1.25. 3, 0. So how many roots should this have? Should have 2.
Yeah.
Okay, let me just zoom out. It has 2 roots. But what do you think will happen if I get closer and closer to the value I can't use? So let's say 1.26. Should I have 2 roots or not? I should still have 2 roots. But do you see what's happening here? It's hang on. No, not that one. There we go. I still have 2 roots. But now what happens if I put in the value 1.25? What graph should I get? I won't have 2 roots. I can't have 2 roots because it's not quadratic anymore. I should have a line. Maybe I should have 1 root. And I do. Let me try and make that a bit clearer. So you see this black line here? It only has 1 root. You have to be careful with that because, for example, here, when we were doing this question, you might have just thought, this is the answer, I'm finished. If k is bigger than -1, I have 2 roots. But it is important that you look here to make sure that you're not saying that you have 2 roots and in this situation you also have 2 roots. Here you can't have 2 roots because it's linear. You can only have 1 root. So for this case, when I'm looking for 2 roots, you just need to take care with this part in the front. Okay, so this is an example of a very hard question on this topic. The good news is, I think this might be a tiny bit too difficult for the exam, but there are questions like this in the exam. So I'll do another one like this, but a little bit easier, just to show you what type you might get in the exam then. So can I scroll down here? Yeah. So type of question you might get in the exam, I don't know. Let's see. X squared plus 2kx, I don't know, plus k squared. Okay. Maybe I made it a little too easy, but it is a good example of what you might get in the exam, because you don't have to worry about the k at the front, because there isn't a k at the front. And 1 root is a little bit easier to do, because if it has 1 root, what do I know the discriminant is? It should be 0. So here we have b squared. Oh wait, that's funny. Yeah. I need to change it so there's at least an answer then. Let me think. How will I change it to make an answer? I'll stick in a -2 here. Why not? So I'll have b squared minus 4ac. That should equal 0. Okay, so we get 4k squared plus, what's that, 8k squared should equal 0. So that means 12k squared should equal 0. So this simple example here means the only way this can have 1 root is if k equals 0. So, I mean, it's a little bit easier because you're not dealing with this. Maybe that's a bit too easy. You don't usually get this as the answer, but it's the right sort of idea for the exam. In the exam, they don't usually put k on the 3 of them, just on 2 of them at most. or sometimes just one of them. Okay, let's see. Yeah, let me do another one actually, because this one too easy perhaps. Can I scroll down? Yeah. Okay, here's one. Minus 7k squared plus 2, no. Minus 7k plus 2 x squared minus 6x plus 1 has no roots. Find k. Okay, I'll just give you a minute to try it first before I do it, since I've done 2 examples like this. So if you can give it a try first. Okay. We have some answers? Yeah? Let's have a look at it. So it has no real roots, so that means the discriminant should be less than 0. So that means b squared minus 4ac less than 0. 36 plus 28k minus 8 less than 0. Yeah, what's that? 36, 28, yeah. Which is, again, nice. There we go. Less than 0. K plus 1 less than 0. So in this example, k must be less than minus 1. Now, we have to be careful here, because if this part in the front was 0, what type of equation would we have left? Linear. We'd have minus 6x plus 1 equals 0. How many solutions does this have? It has 1 solution. So we don't want this to be part of our answer. So we don't want k to equal 2 over 7. Now, is that included in this? No, it's not. So we're good with just this then. This will make it have no real roots then. Yeah? Okay, do you all have that written down? Yeah, let's have a look at the questions here. Okay, scrolling down. Okay, so 1 ABC two can be ABC. And 3 can be C, D, E then.
later, you may